So today our topic will be reaction of metals with the oxygen, number one. Number two, we'll see how they react with acids. Number three, how they react with water. Number four, how they react with hydrogen. Number five, how they react with the chlorine. So we'll take one by one all these. So first of all, we'll start with the oxygen. So we'll write reaction of non-metal with oxygen. Okay dear, so reaction of non-metal with oxygen. First of all, so we'll take, when non-metals just react with oxygen, they form actually oxides, and those are known as non-metal oxides. So first of all, we see when a non-metal react with oxygen, so they form what? Non-metal oxide. Okay dear, so non-metal reacting with oxygen is form a non-metal oxide. This non-metal oxide in nature can be acidic. Okay dear, it can be acidic or it can be neutral. So dear, we are having now oxide, non-metal oxide, and this non-metal oxide in nature can be acidic, it can be neutral. So first of all, we'll see which non-metal is making an acidic or a neutral oxide. First of all, we will take carbon. This carbon is reacting with oxygen in a particular condition, means we have to heat it or we have to burn it, and it will form an oxide that is known as carbon dioxide. So carbon dioxide is a non-metallic oxide. This carbon dioxide, if dissolved in water, will form an acid. So we will see whether this oxide is acidic or it's neutral. So what we have to do, we have to make a solution, or we have to dissolve it in water, we have to mix it in with water. If it shows blue litmus converting to red litmus, or red litmus converting to blue litmus, accordingly we will name that oxide. Okay dear, first of all we are dissolving it in the water. So carbon dioxide, when dissolved in water, what will be the product formed? The product formed will be an acid that is known as carbonic acid, and the formula for that carbonic acid is H2CO3. So what is this? This is an acid and this is known as carbonic acid. So if we take the litmus test, it will convert blue to red. Blue to red. So we know that acids always convert blue to red. Blue to red. Okay dear? So blue litmus is converted into red litmus. So its color is changed into red litmus. So this indicates clearly that this oxide of carbon non-metallic oxide, okay, is having acidic nature, because on dissolving water it is forming an acid that's known as carbonic acid. Now similarly, if we take another non-metal, that is sulfur, so we are reacting sulfur with the oxygen. The reaction will be likewise, and it will form an oxide that is known as sulfur dioxide. Okay dear, This sulfur dioxide is also acidic in nature. So this sulfur can form trioxide also. So we will take that reaction also. Sulfur is reacting with oxygen. It's forming sulfur trioxide, SO3. Okay, here. Now, the reaction is unbalanced, so we have to balance it. We will just find a common factor, that is 2, 3 are 6. If we multiply 3 by 2, it will be 6, or 2 by 3, it is 6. So we are writing 2 here, so 2 3s are 6, or simply we are writing 3 here, so 3 2s are 6. By writing 2 here, this sulfur becomes twice, and so we have to write here this. So the statement of the reaction will be that this sulfur is reacting, 2 atoms of sulfur are reacting with 3 molecules of oxygen to form 2 molecules of sulfur dioxide. Now we can see both of these oxides, that is dioxide and trioxide, they are actually acidic in nature. So when we dissolve them in water, what will be the product form? So simply if we dissolve SO2 in water, so SO2 in water, the product form will be an acid that is known as sulfurous acid. So we have sulfurous acid, that is H2SO3. H2SO3. Now this is sulfurous acid. Okay, dear, now if we dissolve this trioxide in the water, the product formed will be actually a compound that is known as king of chemicals, and acid is actually known as sulfuric acid. So if we dissolve this sulfur trioxide in water, we are getting H2SO4. Okay dear, H2SO4, this is sulfuric acid. Okay dear, this is sulfuric acid. Now see, if we just look that these are actually these are the oxides which are acidic in nature, because on dissolving water they form the acid. So we have another test here. You can check whether this is acidic oxide or basic oxide. Simply, if we take this oxide, say SO2, we are reacting it with a base like a strong base, sodium hydroxide, and the product formed will be the salt, that is Na2SO4, and there will be the production of water, H2O. So if you see, this is a neutralization reaction. This is an example of neutralization reaction. In a neutralization reaction, an acid reacts with a base to form a salt, and the byproduct is the water. Similarly, here you can see that this oxide, sulfur dioxide, is reacting with a base. It's forming a salt and water in addition. So this clearly indicates that sulfur dioxide is having acidic nature. Now, so we can write acid reacting with the base, and it's formed, converted into salt, and this salt is actually known as sodium sulfate. So this is sodium sulfate, no, SO3. SO3, that is salt of sodium sulfite. Okay dear, so this is sodium sulfite, SO3. Now we have to balance this reaction. You can balance it also. We are having here 2 and 3 oxygen, here we are having 3 and 4 oxygen. So what we have to do, we can write here twice. Oh no, it's like this. it's having 2 sodium, so we'll write twice here, twice NaOH. So the balance will be twice NaOH, so SO2, so SO3. So this is balanced reaction now. We are getting a balanced reaction now. It clearly indicates that this oxide of non-metal, that is sulfur oxide, sulfur dioxide, it's having acidic nature, or it's of acidic nature. So this was the reaction of oxygen with the non-metals. Now if we take some neutral oxides, that non-metals can form neutral oxides also. So right here, so the oxide can be acidic and it can be also neutral. So we'll see this carbon is reacting with oxygen, that's monoatomic oxygen. So we'll write here, it will form CO. So that is carbon monoxide. So this will be a gas. We are having a solid, so we are having gas here. So the product will be formed as carbon monoxide. It's also a gas. So balancing this equation, so we have twice carbon reacting, 2 carbon atoms reacting with 1 molecule of oxygen. They will form 2 molecules of carbon monoxide. So this carbon monoxide is a neutral oxide. So this is neutral oxide. Neither it will behave acidic nor basic. So this is carbon monoxide. Carbon monoxide. Okay, here. Similarly, if we are reacting hydrogen, so this hydrogen has not been given a proper position either in metals nor non-metals. So this can be included in both. It's reacting with oxygen, it will form an oxide, so that will be H2O. So we have to balance this now. So this will be H2 gas, so twice. So we can write here 2 molecules of hydrogen are reacting with the molecule of oxygen to form 2 molecules of water. So this oxide of hydrogen is a neutral oxide, non-metallic oxide, neutral. Okay, here. Now we'll see reaction of non-metal with hydrogen. So it will react at different conditions to form the hydrides. So they will form the corresponding hydrides. So we'll take reaction. So we will write the statement here. That is word equation. That's non-metal reacting with hydrogen. They will form non-metal hydride. Okay, here they are forming non-metal hydride. For example, there will be different conditions for this. So if we are reacting this hydrogen with oxygen, so the product formed will be water. So balance it. So we have twice here, so twice. And this condition will occur when we pass an electric spark. Okay, so this will occur in this condition. So hydrogen can readily react with this sulfur without any condition, so it will readily react with sulfur. So we'll write the reaction. Hydrogen is reacting with sulfur, it's forming the hydrogen sulfide, that is H2S. So balance it. So it's like this gas, this will be solid, so it will be hydrogen sulfide simply, and this will be a gas. Okay, now if we take a reaction of nitrogen with hydrogen, so hydrogen is reacting with nitrogen, so it will form a gas, so it will be in diatomic form, this will be also in diatomic form, and it will form an hydride, that is NH3. This is ammonia. So ammonia is formed when we are just increasing the atmospheric pressure to 660 atmospheric pressure. Okay dear, so we have temperature of 775 Kelvin, and this will be converted into NH3. So we have to balance this reaction. Simply what we have to do, we have to write this, and this will be 2 3 is 6. So this is the balance side. We can say that 3 molecules of hydrogen are reacting with a molecule of nitrogen to form a molecule of ammonia. Okay dear, the molecule of ammonia. So now we'll take a reaction with chlorine also. So what will they will form the corresponding chloride. Okay dear. So we'll write a statement that is non-metal plus chlorine will give non-metal chloride. Okay, here they are forming non-metal chloride. Now this reaction will also occur at different conditions. For example, we have hydrogen. This hydrogen is reacting with chlorine, and the product formed will be hydrogen chloride. So this is twice HCl. This will form when we are having diffused sunlight. When we pass sunlight this in the reacting vessel, or we are making this reacting vessel to expose in sunlight, the product formed will be hydrochloric acid or hydrogen chloride. Similarly, we have phosphorus. This phosphorus will react with chlorine, and it will form a product that is known as phosphorus trichloride. So the phosphorus trichloride will be PCl3. So that is phosphorus trichloride. We'll write okay dear, phosphorus trichloride. Now balance it. We have to balance it. It's necessary. The atom will be P4 here. Okay dear. So we have. So we'll write here 4. Okay dear. 4 3s are 12. This is 6 2s are 12. So the balance here. The atom of phosphorus will react 6 molecules of chlorine to form 4 molecules of the phosphorus trichloride. Okay dear, this will be the reaction. Now we can make them react with other solid solutions. So we'll write here non-metal plus salt solution. Okay dear, metal plus salt solution. They will show displacement reaction. Now you know, say we have non-metal A is reacting with the salt solution of non-metal salt of non-metal B. Okay, there will be a displacement reaction. A will displace, so we are getting salt of A plus B. Okay dear, this will be the reaction. So simply we will take an example like sodium bromide, NaBr. Okay dear, NaBr. It's made to react with chlorine. So the product formula will be actually sodium chloride. Okay dear, sodium chloride. So what is the process here? That is, this chlorine is displacing bromine, so we can get bromine here. Okay dear, so this will be liberated in the form of gas. So we have this solid. Okay dear, oh sorry, this is an aqueous solution. This will be an aqueous solution. This is gas when passed through this solution. So we are getting an aqueous solution of sodium chloride. So just we have to balance it. We are having 2 chlorine, so we'll write here 2. That becomes twice. So we are getting Br2 here. We can see the statement that 2 molecules of sodium bromide are reacting with a molecule of chlorine, giving 2 molecules of sodium chloride and a molecule of bromine. Okay dear. So if we reverse this reaction, the reversal of reaction is not possible. Say if we try to react bromine with the chlorine, so the reaction will not occur. Why this reaction will not occur? Because this chlorine is more reactive than bromine, and this is displacing bromine, so the reaction occurs in this phase. So reversal of this reaction is not possible. So now if we see, if we are making this non-metal to react with water, what will happen? So fourth point is that non-metal is being reacted with water, there will be no reaction. So we have to see why not. Because this non-metal is atom. So this is an atom, so we can write atom which accept electron. Okay dear, this is an electron accepting, because this is an electronegative element. Non-metal is an electronegative element. It will not donate electron. Hydrogen will not be utilized, that is hydrogen will not be reduced, that is hydrogen ion will not be reduced to the hydrogen gas. So there will be no reaction. Hydrogen needs an electron to get reduced. Hydrogen needs an electron to get reduced. So there will be no reaction. So similarly, if we are making it to react with acid, so there will be no reaction. Similarly, there will be no reaction. Why? Because the non-metal will not donate electron to break the acid. So acid will not be broken, because acid always donate hydrogen. So it will donate hydrogen ion. So when it will donate hydrogen ion, this ion will accept an electron to form the hydrogen gas. Because this non-metal is not donating an electron, so the hydrogen ion will not be reduced to the hydrogen gas. That is, there will be no reaction. So thank you.